We're going to be looking at how to calculate the number of particles in any substance today, using Avogadros. And we know that Avogadros, one mole of any substance, one mole of any substance is equal to one Avogadro. That is equivalent to the equivalent Avogadro's number of 6.022 times 10 raised to the power 23. So that is what it means. So being that a mole happens to be the unit of measurement of substance in chemistry. So then one mole being equal to this, we are going to be using it, to calculate what we are likely to get in each gram of a substance. For example, from the first question we have there, say that how many atoms are there in 15 grams of oxygen? So we know that um, since one mole of oxygen, now we're talking about one mole of oxygen. One mole of oxygen is equal to 6.02 times 6.022 times 10 raised to the power 23. That is for the one mole. And we know that relative molecular mass or molar mass of oxygen is the relative molecular mass is 16. Since oxygen is diatomic, multiply by 2, we have 32. That means we have 32 grams of oxygen in one mole. So since one mole is the mass of a substance expressed in what? Expressed in gram. Expressing it in grams, we have 32 grams. One mole represents this mass. One mole of a substance represents this for oxygen. So in that case, since we are looking for the grams there, we can also substitute this for what we have as mole here. So what I'm going to do here, what it simply means that since you know that one mole is equal to 32 grams of oxygen, simply means that 32 grams of oxygen, the 2 grams of oxygen will be equal to 6.022 times 10 raised to the power 23. Now we have that. So what are we likely to have in 15 grams? In 15 grams, then 15 grams will be 15 grams of oxygen. The atoms we have there will be times 10, 6.022 times 10 raised to the power 23 all over 32 multiplied by 15. So by doing this, we are going to be minus 15 multiplied by 32. What we have is the number of atoms we have there should be 2.82 times 10 raised to the power 23 atoms. That is what we have, the number of atoms, because the question said how many atoms are there in 15 grams of oxygen. This is what we have. So in the same way, we're going to be trying the second one. Let's see how we're going to solve the second one. Talking about molecules, you calculate the number of molecules of chlorine in 30 grams of chlorine. So in the same way, what we have here, we know that relative atomic mass of chlorine is this, multiplied by 2, because chlorine is diatomic, we have 71. We have 71. That is to say, since one mole of chlorine is equal to 6.022 times 10 raised to the power 23, what it simply means then 71 grams of chlorine will give us equal to 6.022 times 10 raised to the power 23. Then 30 grams will then be 30 grams will be 6.022 times 10 raised to the power 23 multiply by 71 divide by 71 multiply by 30 multiply by 30. So what we have will be divide by 71. What we have is 2.5 times 10 raised to the power 23. 23 what? Molecules. So that is the number of molecules we have. Thank you for being part of the class. We want to encourage you to subscribe if you are joining for the first time. And if you have any question, you can leave it in the comment section. And make sure you share and like. Thank you.